And the other type of problem in which all of these concepts appear a lot are the kinematics problems. These two things are very closely related because, as we were mentioning before, every derivative is the rate of change of something. And in terms of kinematics, the something are the physical properties of a particle. So speed of the particle is the rate of change of position. If the position is changing slowly, that is a small speed. If the position is changing faster, that is a large speed. So F is going to be position, F prime is going to be speed, and the rate of change of F prime, so F double prime, what is the rate of change of speed? It's acceleration. We actually have to be kind of careful here because this vocabulary comes from physics. So speed is not actually what I need to say. I want to say velocity because velocity can be positive or negative. So there is one established direction, say moving to the right is positive. So a positive velocity goes that way, negative velocity particle goes this way, but the speed doesn't have a direction. The speed is just a number in absolute value. And this comes up in a lot of problems, okay? So pay attention to that when it comes up. So let's go ahead and solve these problems. Most of them are meant to be done with a calculator. So we're going to go through that as we solve the problems. And just like in that other question where we were asked questions about f, but we're actually looking at the graph of f prime, in kinematics problems, you have to be really careful with what function is he giving you. Because in this first example, it is actually s, the position of the particle. S is the letter that he usually chooses for that. But in other questions, it's going to be velocity, or sometimes it could be even acceleration. So you have to be careful with what you are given and use these relationships in the appropriate way. So in question one, he gave us a function, he gave us a domain. This is a calculator question. The first thing that you should do is just type it and look at it. Look at it in the domain that was given in the function, okay? It's a common mistake for people to just look too far away. So I've put the graph here from 0 to 5. And the first question is find the maximum distance. So the word maximum makes you want to look at the maximum. But we are going to be careful with the words distance in the same way as we have to be careful with the words speed and velocity, because there are also two different words for position. One that can be positive or negative and the other one that can't. So we have distance and displacement. Distance is in the same category as speed. Nobody ever wants to talk about a negative speed or a negative distance. How far away is one thing from the other? It's never negative 5 meters, okay? So distance is always going to be a positive number. When he wants to talk about displacement to the right is positive and displacement to the left is negative, then he's going to use the word displacement, which is why displacement is the one that better describes what the function actually is, just like velocity better describes the other function, because the functions have positive and negative values, while the words distance and speed never refer to negative values. So anyway, the question is using the word distance, which means he is asking what is the biggest one in absolute value. And this one is so much bigger than the other one. I'm not going to pick up my calculator to find the actual value, but the point is that this point has an x and the y coordinate. And because he asked for the distance, not the time, then the answer that you want here is the y coordinate of that point, okay? I am trusting that you just know how to use your calculator to find that, so I don't have to do it. But for letter B of this question, find the acceleration of the particle at the instant it first changes direction. Well, first we have to figure out what is the instant when it first changes direction, and then find the acceleration at that moment that we found. Changing direction is either going to be here, because I was going one way and now I'm going another way, or here, because I changed direction in the other way around. So changing direction means a turning point of f. And in this question, the function that we are looking at is f. This is not a trick. So we're just going to look at turning points in the graph. The instant it first changes direction is the first turning point, which is this one. It does change direction again later, but the question doesn't care about that. So the t that we are looking for is the x coordinate of that first turning point. I think I remember that was 162. I've done this question before in another video, so I am going to play a part of that video now because it has a very interesting calculator trick to get to the acceleration at that value of time. X equals 1.52. I'm going to use it to three significant figures, is the moment when this particle first changes direction. So acceleration is about the second derivative. Of course, he's not going to ask me what is the speed of the particle when it changes direction, because that has an obvious answer. The speed is 0 when I'm changing direction. I have to stop in order to go the other way. I want the acceleration. And I do have this menu to find the first derivative at a point, which is the speed, but I don't have a menu here to find the second derivative at a point, which is the acceleration. But what I want to do is to graph another function together with that one. I want to graph the derivative function so that then I can ask this menu for the derivative of the derivative, which is then going to be the second derivative of the original function. I'm going to say this again because conceptually this is the important part, so you do have to understand this. I am looking for the second derivative at a point. I only have a tool that gives me the first derivative. So I'm not going to ask for the derivative of this function at that point. I'm going to ask for the derivative of the derivative function at that same point. So that will give me the second derivative, which is the acceleration that I want. Okay. But this is the reason why a lot of students at this point think, well, even though this is a paper 2 question, I am going to have to pick up pen and paper and write down what the derivative of this function is. I'm going to have to use the product rule so that I can come here on the second line and type the function that is the derivative of that. But that's the trick that I want to show you. You don't have to take the derivative of this function in order to type it if the result that you want is just to see the graph. What you can do is to go here in the math button, where you have, among other things, you have the derivative of a function. You can choose that, and it's pretty much the same notation as it would be if you were using this button outside of this functions screen. So you just want ddx, and here you want your original function, but you don't need to type the whole thing again because you've already typed it and it's called y1 now. So you need to put the y1 in there. There's a way to do that. If you see that green F4 thing up there, let's reach that. Green button, F4. Then it opens up this list. You can choose whichever one you want. Of course, I want to choose y1 because I want ddx of the thing that is currently called y1, and I want that at a point because this menu that came from the math button is not to take the derivative analytically. It's not to use the product rule and whatever. It's just to calculate numerically the value of the derivative at a point. But I want it as a function. I don't want just one point. I want all points so that it creates a graph. So my point is x. So it looks really weird in terms of notation because it says x equals x, but that is just the way that the calculator works. So now let's look at that graph. There you go. That is the derivative function. And now I'm looking at both of them, and I didn't have to calculate any derivative by hand. I'm still going to look at it a little bit to try to convince you that the red thing that we're seeing is actually the derivative function of the blue one. So let's look at some key points. For example, the local maximum. The derivative should be 0. And there you go, the derivative is 0. So what else? The turning point of the derivative. That should match an inflection point of the original function. And yeah, that looks like an inflection point, right? You sort of see concavity up before here and concavity down after that. So the red one is the speed function. The blue one is the position function. Red is the speed function. But what I want is the acceleration at point 1.52. So I am going to use the second calc menu to ask for the derivative, but I want the derivative of the red function, right? Right now it's clearly looking at the blue function, so let's change it to the red function. And remember that it's not going to ask me for the value of x. I just have to tell it that it's 1.52 without being asked. So there you go. The derivative of the derivative function at that point is negative 8.92. So that is the acceleration of the particle at that point. Moving on to the next question, this one is giving us the velocity, okay? So now we have to think in terms of this is f prime. The acceleration is 0 at this time. So f double prime of that time value is 0. Why? Because the acceleration is the derivative of the speed. This is also a calculator question, okay? You can do it by graphing, but we do know how to take derivatives, right? So for the purposes of the video, let's just take the derivative of the function and write it down here. Of course, I don't plan to solve this by hand because it's not the type of equation that can be solved by hand. Having a t inside of a cosine and then another t outside, that kind of thing just can't be done by hand. So don't waste your time trying. But we do need to know that this is what we want. We want the acceleration to be 0. So we want a solution to this equation. Do that in whatever way you prefer in your calculator and you will have your answer. But you don't have to do it by solving the equation, okay? Because in an exam, I would not like you to have actually calculated the second derivative. I want you to find where the second derivative is 0 by looking at where the first derivative has a turning point, a maximum or minimum. F prime is what I want you to look at because it's what the question gave us, okay? So that you don't run any risk of making a mistake when you calculated this one. So what you're going to do is to plot the function that was given in the question, which is this one, and it represents the speed. You want the acceleration to be 0. That is where the speed has a turning point. And the question said the domain is from 0 to 1. So you're only looking at this function from here to here. The turning point is here. And then you're going to use your calculator to find the coordinates of that point without calculating any derivative at all. Now part B is asking for distance traveled. And remember, we were talking up here about the difference between distance and displacement. So the use of this word is not accidental. In fact, the formula booklet makes that distinction. Distance is one thing and displacement is another thing. Both of those formulas involve integrals, and I realize I haven't mentioned this in this video yet, but we are talking about the position of a particle, the velocity of the particle, and the acceleration of the particle. And we've mentioned explicitly who is the rate of change of who. So if you take the rate of change of the position, that is the velocity, so this is the derivative. And the rate of change of velocity, the changing speed, that's acceleration. So this is another derivative. This is the part that we've already mentioned. But the thing is that we also know from other classes, other days, we know the fundamental theorem of calculus, and we know that to revert the operation of derivative, we have to use an integral. So if the acceleration is the derivative of the velocity is going to be the integral of the acceleration. And the one that we are talking about at this moment, if the velocity is the derivative of the position, then the position is going to be the integral of the velocity. But what the formula booklet is showing us is that this can happen in two different ways, either with an absolute value in the velocity or without an absolute value in the velocity. And this has to do with all of that vocabulary. Who has sign? Who can be positive and negative, and who can't? And the thing is that distance can't be negative, which is why we put an absolute value in this one. Of course, it is logical, it makes sense, but you don't have to memorize it because it is in the formula booklet, so please look it up every time you're going to need it. And every time he's talking about this, he's always going to say distance traveled, okay? It's almost like a magic word. When you see this word, you know that that is what you are supposed to do. So here it is, distance traveled. I'm going to use this formula. And the function that I'm going to integrate, v of t, is this function here. So the thing he's calling S1 is the distance traveled from t equals 0 to the one that we just found here, of the absolute value of the function that the problem gave us. Use your calculator to do that. You're going to find a number. And then he says S2 is again the distance traveled, but between t and 1. So you do the same integral, but with different limits of integration. Also something that you're doing in your calculator, okay? Don't waste time doing this by hand. And then his actual question is, show that S2 is bigger than S1, and then you just say, well, this number is bigger than this number. But make sure it actually is, okay? Because he's giving you a hint. If your numbers are the other way around, one is smaller than the other, then double check your work. It means you've done something wrong. So this is the first thing that you have to be looking at in all of these questions, right? Which one of the functions is given to me? In this case of exercise 3, he is giving us S, which is the first one. It's the position of the particle. And then you have to interpret all the questions in terms of that one function that you have. In this question, he asks about when does the particle first come to rest? Come to rest means that it is resting. It is stopped. The speed is 0. So we are looking for v is equal to 0. But we have to think of that in terms of s, which was the function that was given to us in the question. So that is the derivative of s. We are looking for a point where s has a derivative equal to 0, which is then a turning point of s, right? Just like we did in the previous question. You're going to plot s and you're going to look at the first turning point because that's when the particle first comes to rest. And then the total distance that the particle travels. This is distance traveled again. It's that integral of the absolute value of the speed, but the question didn't give us the speed, so it's s prime that comes here. That is the speed. And in the first q seconds, it's from 0 to q. Q was the answer to part A. And you might think that because you're taking an integral of the derivative, then you might as well not even do anything because those cancel each other out. So the answer should just be S. But don't do that, okay? Because the absolute value is changing what happens in here potentially. It depends on whether the function is going to take on negative values in that interval or not. And you don't want to have to think about that. Just do the integral of the absolute value of the derivative because that's safer. Again, you don't have to do this derivative algebraically if this is a paper 2, okay? You can use the same calculator tricks that we've just been using. You go into the graphing screen and you type as y1 the function that it gave you. And make sure that your calculator is in radians, okay? Every time that your function involves in any way a trigonometric function, the calculator needs to be in radians. So now you're going to get out of this screen and you want to do an integral. I think you know where the integral is. It's here in the math button, this option right here. And then you first put the limits of integration. I want from 0 to q in the question, but I didn't calculate what q is. So I'm just going to put from 0 to 1, just to have something there. Okay, so now here inside of the integral, I want to put the absolute value of the function. So where can I find the absolute value? Again, you go to the math button, but now you have to go to the right and find this num menu here, okay? It is the first thing on the list, ABS, it's absolute value. And now you have an absolute value inside of your integral. We want to put the function there. The function that has already been typed in the y equals. So what I wanted to show you is that the trick that I showed you before about the alpha F4, it works here as well, okay? It doesn't just work in the same screen where the Y1 was actually typed. So you can put that in here as well. But that's not really what we want, right? We don't want the integral of the absolute value of the function. It's the integral of the absolute value of the derivative of the function. So I have to put a derivative here. That's on the same menu, math, just scroll down until you find the derivative. And then that's going to put it inside of that integral. And you have to fill it in as d dx of the y1. That's where the y1 goes. The notation is going to look strange here because this blinking square is where we usually put the point at which we are looking at the derivative. But right now it's just x equals x because this x is the same x as we are going to put as the variable for the integration. And this looks absolutely crazy in terms of notation. This only makes sense for the calculator, but it does work. Exercise 4 is giving us the speed instead of the position. So that is not going to change what kind of questions he asks, but it's going to change how we interpret the graph and the function. For example, he starts by saying that the object first comes to rest at k. And in the previous question, we were interpreting comes to rest as a turning point because that is speed equals 0. But here, the speed equals 0 is not at the turning points because this function is the speed. So the speed equals 0 is here. This is the point k. So he asks a lot of questions. Displacement from the origin at t equals 1. This is s of 1. Find an expression for the acceleration of the object. Well, acceleration is the derivative of speed. And in this case, he is asking for an expression. So this one you're actually going to do by hand, okay? The calculator is not going to help you with this one. Good thing he gave us an easy function. It's a polynomial, so the acceleration is this. Hence, find the greatest speed before it comes to rest. Well, before it comes to rest is before that point k that we marked, and the greatest speed, because we are looking at a graph of speed, the greatest speed in this interval is here. But he said the word hence in that question right after having us algebraically calculate this. So this time it will not do to use the calculator to find this maximum point, okay? Because of the word hence right after finding the expression, you actually do have to put that expression equal to 0. And then if it's a calculator question, you can use the calculator to solve that equation. But it is a quadratic equation. You can also do that by hand. So for the next item, to contrast with item C, he is also asking for greatest speed, but in C, it was before it comes to rest. Now it is in this interval here. And we suspect that the answer to both questions is going to be different, right? So I think that the speed here at the end of the interval is going to be bigger than the speed that we found before. Again, this one is a negative number and that one is a positive number, but speed doesn't have sign, so this speed is greater than the other one. And then you just have to calculate v of 4. Write down an expression that represents the distance traveled. Distance traveled is the integral of the absolute value of the speed. It says do not evaluate the expression. Okay, so this was definitely a paper 1 question. He doesn't want you to use the calculator at all. We do need the limits of integration for this expression. He says while the speed is increasing, let's check out where the speed is increasing. It's from here to here. These two are the points where the derivative of the speed is 0, right? So let's solve the quadratic equation. Getting 2 and a third, so clearly this is 2 and this is a third. So these are the limits of integration that I put here. So coming back to the calculations that I skipped along the way because I thought this might be a calculator question. V of 4 is easy to do. You just plug the number 4 into the expression that the question gave you. But item A was asking for S of 1. And S is the integral of V. So I was wondering if the question actually wants us to do that without a calculator. But I think it's very likely that he does because this is 5 marks. So it's totally justified to do an indefinite integral. You get a plus C, which is going to be 0 because of this information here that S of 0 is equal to 0. And then plugging in T equals 1 here to get S of 1. That's a lot of work, but it's also 5 marks, so it's worth it. Question 5 is giving us the displacement. This is always the first thing that I look at, because if I don't, I run the risk of doing the whole question wrong. The initial displacement is S of 0, so just plug T equals 0 into that. The velocity when T equals 2 is S prime of 2. But this one is a calculator question, okay? So you're just going to put exactly this in the calculator screen, and you're going to go into the menu to find the derivative at a point, which is the point x equals 2. Now determine the intervals of time when the particle is moving away from the point P. The point P is its initial point, okay? So the point P is the origin. It's when the value of the function is at 0. It's moving away from P here when it's increasing, and from here to here because it's also increasing. And notice that he did say intervals, plural, okay? Because sometimes in these questions that have more than one answer, a common mistake is for the student to just give one answer and then ignore the other answers. So I think you should pay attention to whether the question is singular or plural, because that's a very strong hint that there's more than one. And in order to find out these intervals, you just have to calculate with the calculator the points of maximum and minimum of the function, and then write down this interval and this interval. But there is something interesting here to mention that didn't happen in this question, but could happen some other time, is that when he says moving away from point P, our function here was just positive everywhere, but that's not always the case. So I said in the increasing parts, it's moving away from P, this interval and this interval, but on the other side of P, it's not going to be the increasing intervals, it's the decreasing ones, because we're moving away in the other direction. So if this was the case, it would have been a trickier question in which you would have 3 intervals from the beginning of the domain to the maximum, from a minimum to a maximum, just like we had this one. And the third one would be from a 0 to a minimum. In that case, there would be 3 intervals where the particle is moving away from the point of origin. The question is not over. He also says that the acceleration is 0 at 2 points. So let's think back to what this means. The acceleration is 0. And the function we're looking at is s. So the acceleration is 0 means inflection points. We're looking for inflection points of this function, and we have to do that by making maximum use of the calculator, okay? We don't want to waste time and risk making mistakes by trying to do these things algebraically. No part of it. So you're just going to type the function itself, and you're going to look for its inflection points. So you want to look at the second derivative of this being equal to 0. This is almost the same trick as I showed you before. You're going to make your calculator show you the graph of the first derivative of this function. Of course, this works differently in the technology that I'm using right now than it does in your calculator, but I've already showed you how to do that. And then you want the first derivative to have a maximum or minimum. Those are the points that you're looking for. So in 2 points that happens. There is a minimum at 1 point something, and there is a maximum at 5 point something. I know this is where they are in the picture because I am visualizing the tangent line, which is crossing the function. The other point is the same thing. It's the part where the function looks most like a line, and this line goes up above the function on one side and below the function on the other side. This is how you recognize inflection points. So yeah, B was less than C, so this one is going to be B, this one is going to be C. And then to wrap up the question, he says, find the total distance traveled between B and C. So again, it's an integral from B to C of the absolute value of S prime of t, which you are going to do in exactly the same way as I showed you in the other question that required this. And finally, question 6, the last one, is giving us the speed this time. So determine when the particle changes the direction of motion. It changes the direction when the speed is 0. It's going one way, stops, and goes back the other way. So we need to find v is equal to 0. Find the times when the acceleration is an arbitrary number that he gave us. Okay, so the derivative of the function needs to be equal to negative 1.9. So again, this is the function. You're going to look at the derivative of the function, which in terms of the calculator is the same thing, but in terms of the question now, the blue one represents the speed and the orange one represents the acceleration. And the acceleration is the thing that we want to be equal to negative 1.9. So we include a horizontal line at y equals negative 1.9, and we look for the intersection points. The domain in this question is only until 3, so we don't care about that 6 point something over there. It's just this point and this point. The x-coordinates of those points are the times, so it's 226 and 296. Again, keeping in mind that the question did ask for that in plural, okay? So don't just give me one. And now I want the acceleration when the speed is greatest. So first let's find out where the speed is greatest. The speed is the blue function, so we can clearly see that it's greatest at t equals 3, which is the edge of the domain. So finding the acceleration at that point is finding v prime at 3, which you just look at the orange function that we had just graphed.